Hi, Algebra 1 students. This is a 9-1 video. It says day 2. It might actually be day 3, but I'm just going to say page 5 in your chapter 9 notes. And we are starting out with a warm-up, so I would like you to do that warm-up. And just like always, pause the video and then check your answers. So this first one is review from chapter 7. Remember, when you have a subtraction, you need to distribute the negative. This is from yesterday's lesson. So that is a jailbreak with a number and a variable. And this is also chapter 7. So please pause the video and try this warm up. So hopefully you paused the video and tried this warm up, and your answer for this first one should have been negative 2x squared plus 4x plus 8. So I'm going to let you check that answer. That is review, so I don't think I'm going to go through that one. This one is kind of new, so we'll go through this again. You want to jailbreak your 48, which is 2 times 24, and 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So those are all my prime numbers. So this is the same as 4 twos, 2 times 2 times 2 times 2 times 3. Let's see if I can squeeze in 5 x's. 1, 2, 3, 4, 5. And then the index is 2, or that invisible index that you can't see. So I need groups of 2 to escape. And then I have 2 x's there, 2 x's there. So who's left? That 3 and that x. So make sure you're writing neatly so you can figure out who's left and who escaped. So it looks like outside the jail, I'm going to put my answer down here. I have 2, 2, and x. So 2 times 2 times x times x. And inside the jail, I have a 3 and an x. Didn't need such big jail there. So my final answer is multiply everything that's outside the jail. I get 4x squared, and 3x is inside. Okay, this one's a little different. It says find the value of k. This is what I'm asking for. And I don't really know what to do over here because I don't know k, but I do know how to do that. That's the same as 4x plus 5 times 4x plus 5. Again, that is from chapter 7. Most of you, I believe, are doing a box on this. Few of you are doing distributive property, but most of you are doing a box. So multiply the outside to get the inside. And that's what I get, 16x squared, 20x, 20x, and 25. Again, check those diagonals. Those are like terms. So this ends up to be 16x squared plus 40x plus 25. So that's this side of the equal sign. And then they have equals 16x squared. Okay, that's what I got. Plus 40x plus 20. No, they don't have 40x up there. Hang on, sorry about that. They have kx. I'm copying what they have. So I'm just copying this down here. Plus 25. So if you look at both sides, 16x squared, yeah, I got that. This middle term where the k is, I got 40x. The last terms match also. So that means this middle term must be equal to this middle term. So that means k must be 40. Okay. All right. Now, example 4 looks a little different. Hopefully it looks a little different to you. Let me slide over here a little. And this little box kind of explains it. It says the index tells you how many numbers / variables you need to jailbreak. So I like to say this is like a higher security jail. You need groups of 3 to escape, but only 1 makes it out alive. So for these, when your index is 3, When I go to circling who escapes, I'm going to look for groups of 3. Now, we have not seen a negative inside the jail before. So the first thing I want you to note is that that is the same as -1 times 135. And then I want you to put this in your notes. -1 always escapes. So they do not need a partner. If you have a -1 in jail, they always escape. So I'm just going to leave that. I know that's going to escape. Now I'm going to do my tree on 135. 135 is 3 times 45. 45 is 3 times 15. And 15 is 3 times 5. So my prime numbers are 3, 3, 3, and 5. These are not prime, so I'm going to X those off and kind of forget about them. Okay, so what I have up here now is I have a third root. Don't forget to write your index. And notice it should be very small. It shouldn't look like a number outside the jail. It should look like a very small number 3 sitting right inside that V. And then inside the jail, I have that -1, and then I have 3 3's. So -1 times 3 times 3 times 3 times 5. Now, if you put this in your calculator, you would get -135. I'll show you. -1 times 3 times 3 times 3 times 5, -135. I encourage you to do this to check your work. Now, high security. You need a group of 3 to even try to escape, but still only one will make it out alive. -1 always escapes. So what is left in this jail? Just the 5. So outside my jail, I have -1 times 3. This is a third root jail, so put that little 3 right there, and then your 5. -1 times 3, multiply everything outside the jail. So that is sitting outside the jail. And then there is my index. So make sure that your index doesn't look like another number sitting outside the jail. Make it really small. Put it right in that V. So that is how I want to jailbreak that. Now B is also a big number again, and I note I'm looking for groups of 3. So 2 does not go into 729, but 3 does. So it's 3 times 243. 2 doesn't go into 243, but 3 does. 3 times 81. 81, again, 2 does not go into 81, but 3 does. It's 3 times 27. 27 is 3 times 9. And 9, you probably know, is 3 times 3. So I have 1, 2, 3, 4, 5, 6 3's. Cross off all these non-prime numbers. So this is the same as, going to need a big long jail here with an index 3. I like to think of that index as the sign outside the jail. So the sign on this jail is a 3. And then I want inside 1, 2, 3, 4, 5, 6 3's. 1, 2, 3, 4, 5, 6. Okay, now it's a high security jail. Its sign tells you right there. You need groups of 3 to try to escape this jail. There's a group of 3, 1 makes it out alive. There's a group of 3, 1 makes it out alive. Everybody in the jail escaped because every number is circled in the jail. So the jail is now empty. Tear down the jail. So your answer will not have a radical in it or a jail or a third root. It's just going to have what is outside the jail. So what's outside the jail is a 3 times a 3. Remember, you multiply whatever's outside the jail. So right here's my empty jail. There's nothing in it. So I don't have a jail. So 3 times 3 is 9. That's my answer. So 729 is what we call, 729 is a perfect cube, because 9 to the third power, so if you multiply 9 times 9 times 9 equals 729. That's why when you take the third root of 729, you get a 9. So you could just put this in your notes. It's kind of an interesting little fact. We haven't talked a lot about perfect cubes. Okay, this one's also a biggie. I think I'm going to rewrite this x to the fifth as x to the third times x to the second. So that's going to make it a little easier, because I know x to the third and my index is 3. 3 divided by 3 is going to be x to the 1. 3 divided by 3 is 1. So I know from these 3 x's, 1 x will escape. So now I'm going to think, okay, what does this problem look like now? This x is on the outside. So I have a negative. I have an x on the outside. Then I have a third root. I have another negative, 129, and x squared. I know that x squared is going to be left in the jail. And if you think about it, we had x to the fifth, 1, 2, 3, 4, 5. We would circle groups of 3, and 1 x would get out, and 2 would be left. So this would be the long way, this would be the shortcut. Either way, 1 x on the outside, 2 x's or x squared left on the inside. Okay, now remember this is negative 1 times 192. This negative 1 is also going to escape. Okay, so now we got to do a big old tree on 192. I'm going to tell you, I ran out of room, so I ended up finishing my tree over here. You might need to do the same. This is 2 times 96. 96 is 2 times 48. 48 is 2 times 24. So now I'm going to come up here. 24 is 2 times 12. 12 is 2 times 6. And finally, 6 is 2 times 3. Okay, let's see what we have here. We have a negative 1. 2, 2, 2. Cross off that 24, cross off that 48, cross off that 96, cross off that 192. And then we have another 2 here, cross off that 12, another 2, cross off that 6, and a 2 and a 3. So make sure you have this in your notes. That's a big one. So I have 1, 2, 3, 4, 5, 6 2s and a 3. So I'm going to write this right over here. So what I have outside is negative x to the third. And then I'm going to draw a big old cubed root there. This is a cubed root. I'm going to put a little 3 there. And I'm going to put the negative 1 and 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, 5, 6, and a 3. Okay, I am actually going to erase this because I need a little more room. Okay, negative 1 always escapes. Don't forget that. Negative 1 on the outside. Groups of 3. There's a group of 3. Only 1 makes it out alive. Ooh, there's another group of 3. Only 1 makes it out alive. Who's stuck? Just that 3. Okay, so now let's think. What do we have on the outside? We have this negative x squared sitting on the outside. You can kind of think of that like the getaway car waiting on the outside. That shouldn't be an x to the third. That should just be an x. Sorry about that. That's my mistake. I think back here I saw this 3 and I thought it was an x to the third. That's actually my index. So just a negative x on the outside. Now what I'm going to multiply by is a negative 1 and a 2 and a 2. So all of these are also on the outside. And the only thing that's left is a 3. Oh, I forgot my x squared also. See this x squared over here that I said was stuck? That's also left in the jail. So 3x squared. Okay, make sure you're good. Check your notes because I made a couple little copying errors there. Now, we want to multiply all these. So when I multiply two negatives, I get a positive. 1 times 2 times 2 is 4. So I have 4 and 1x. So if you multiply all these numbers, negative times a negative is going to get you a positive, and 1 times 2 times 2 is 4, and there's your x, and then 3x squared. Okay, that one was a bugger. So hopefully yours are not going to be as bad as that. Please turn the page to page 6. Remember, if you missed any of these notes, the great thing about a video is you can pause it. Okay, this is kind of long, your turns. So you should pause the video and try all those. Those of you who are speedy, we have a challenge one for you down here. But pause the video and try these. This is for you to check your work. So that is the answer there for that one, which says B. Really should probably be an A. Little mistake in your notes there. Okay, the answer for B over here is negative 4x outside the jail. And remember, this is a third root, and we have an x squared left inside. So if you did not get these, go back and see if you can find your mistake. This one, we had a negative outside, so that tells me my answer should be negative, and it is. Negative 9m outside and m inside. This one, you had to find the error. Well, I can see right here, this is not a prime number. So they didn't make their tree go far enough. They should have written this as 2 times 9 and then 3 times 3. So what they should have are these two 2's that they had, but then they needed to jailbreak further. Times 2 times 3 times 3. So they didn't do their tree all the way down to prime numbers. I should have all prime numbers in here. 18 is not a prime number. So if I jailbreak this, I have a 2 on the outside and a 3 on the outside. So outside I have 2 times 3, and that 2 is stuck. So I would get 6 square root of 2. Okay, and then the challenge one, if you tried that, bravo. If you got it right, even more bravo. This is a 5th root, super high security. So you had to circle groups of 5 for this one. That is the answer. Okay, that is it for this video.